Hello, my name is Ireland Roberts, and this is my presentation of my electroresistivity survey. This is for Dr. Dixit's environmental geoscience class, and it's our final project. So what is electroresistivity survey? This is a survey that measures the ability of Earth to conduct an electrical current. The resistivity of the material depends upon the salinity in the pore fluid in the material, fractures within the material, clay that could be found, as well as the porosity and the permeability. So why is this important? The electroresistivity surveying can be useful to infer geologic properties of minerals in the subsurface. This can be the exploration of mineral deposits, groundwater reservoirs, waterways, contamination, karst determination, man-made factors, and so many more. I really like this figure because it actually shows how the electric currents will work. So you have the zone in which it is like your probes, your electrostatic are set up, and then this is kind of how it does, like how it works, as you could say. A current is passed from one electrode to another, and then determining how fast it comes back and all the other kind of stuff can show the resistivity of the minerals in this area. So for my electroresistivity survey, I did this in a backyard Northern Kentucky home. It was actually in preparation for a backyard remodeling. They wanted to possibly put a pool back here, if not just have like a really nice patio. And the thing about this area is that there is an abundance of tubes that go through here that lie from the center of the backyard into the house. So we do believe that there might be a septic tank in this area, and this orange arrow is actually pointing to it. So for this, there is the hypothesis, and we believe we would find a septic tank or prior evidence of one, whether it be a void space or just a lot of minerals that don't make sense to be there. This is due to the abundance of pipes that run from the center of the backyard into the house, as well as that this is an older house that has been restored, and there's a lot of water pipes that have been installed, and they look newer, as well as when this house was built, it would be to believe that it would actually have a septic tank and a well system, because it was before the believed installed date of the water pipes that run from a water treatment plant to the house. So there's many things that go into doing an electroresistivity survey, and these are the things that are the main components. First, you have your laptop, and that laptop is connected to a supersting. The supersting is what tells the electrodes to send out the pulses that it's going to. A switch box, and this is purely pretty much an on and off switch that you connect things to. Exposed wire with conduits and metal probes. And lastly, this is all connected to a battery, and that's what actually powers everything, as well as sends the currents. Each part is very important. The laptop, you can configure what you're wanting to have done, as well as this is what the supersting sends the graphs to, which you can then read. The switch box, like I said, it is just a box that pretty much powers on and off and everything plugs into. Wires with conduits, these are really, really important. It's long yellow wires that have these exposed metal pieces, which are the conduits, that are then attached by a metal pipe, a metal probe, or electrode via pretty much just like a spring, and this is all that goes into it. Really cool stuff. So there are basic wires set up, and here's a picture of what it looked like. I apologize, when it got blown up it became a little distorted, but each electrode is placed about 1 meter apart from each other. This of course is approximate. I had a tape measure laid out, so I hope it was correct. And then each electrode was placed at a depth of approximately 5 inches. They're at this length and they're at that distance into the ground because it has to do with the clarity as well as the the outcome in the project. And then the exposed conduits, which you can see are attached to the yellow wire, they are attached and they are hooked to each electrode. And then what you can't see as behind this picture is where the switch box then connects these two together, then that's connected to the supersting, it's all connected to a battery, and last but not least, it is plugged into my computer. So 2 surveys were done, And the first one was a dipole survey. I chose this one because it was actually just a very basic setup, as well. It's a commonly done survey. When I did some research before doing this, most of them will do these dipole surveys. The previous slide showed how I set up my wires and my electrodes. So it was at the 1 meter distance, 5 inches deep. This is a really interesting picture. It has this equation which shows why you're doing the distance you are, as well as it just shows you have A to B and M to N, and it's showing like how the different currents will go through. And next one I did was the Schlumberger survey. I chose this one primarily because I was interested in it. It does have a much higher resolution, but it did have the negative effect of a very smaller depth reading. They both have a 0 to 11 meter distance that it read, but the dipole read about 2 to 4 meters in. This only read maybe a meter in depth, and that was a really big disadvantage. But with this one, I actually did have to move the electrodes and the conduits. I apologize for not having a picture, but you want it to be about 1/5 the spacing as the previous survey, so approximately 10 inches, and then as well as you push the electrodes into a depth of about 6 inches. All this will do is when you have a shorter distance and deeper down, it is going to make it a higher resolution and a cleaner image. I was just curious to know how that would work, and it turned out really interesting. It showed me different things. This is an image that Dr. Dixit has supplied. I call it my resistivity key. This will become very important, as you'll see in the next coming slides, but this is really interesting because it can actually show what the different colors mean. And pretty much all these colors mean is the resistivity. So for instance, your limestones and your dolomites have a higher resistivity as your coal and shales. Same thing with the igneous and metamorphic rocks. They'll have more or higher resistivity of your massive sulfides. So this is what I got from my dipole graph. I apologize that there is not a north arrow on this. I forgot to put one in, and I was worried if I put one in now, it would be out of place. But as you can see from this, on the right side is your key, or your legend, should I say, and this shows the resistivity, and you can see all the different areas. And like I said, this goes to about 2.5 meters, and 0 to 11 meters deep, sorry, and then 0 to 11 in distance. And if we go down here, the area shows a large sheet of limestone near the surface, which would have been that blue. If we want to go back to this, if you see down here, it has the limestones and a dolomite in that blue, which you can then see in the center area of this. As well as it shows some shales surrounding on each side, and sandstones possibly can be determined underlying the limestone. If you see, your sandstones are more, like your shales, should I say, are more of a yellow, and then your sandstones, I am going to guess with this one because of the area. And then with the limestone, I was able to find that because one, it was that blue color, and then after I got this done, they had somebody come out and they actually dug deep, and I was actually able to see the limestone, which I feel like might have been cheating a little bit, but it was really cool to see the differences and to actually determine whether or not my belief was correct or not. And this is the Schlumberger graph. Like I said, it has the same distance that it was done, but it's not as deep, but the resolution is higher. You're able to see that blue right there, which would have been that limestone sheet. That limestone sheet, actually, I should have previously said this, is believed to have been maybe an old patio. It's kind of odd that it would be made out of like this big chunk of limestone, but it's very, very flat. And they believe maybe it was just covered up as like the time goes on. Not to mention there's a big gap between the door and the bottom of the ground. So they think it might have been dug out and then pretty much just thrown back into the ground and then recovered, just because it was cheaper to do it that way. So I was able to, same thing was able to be seen, except possibly the additions of a massive sulfide or trace waters. This would have been that really dark really dark pinks and reds. That one I'm not entirely sure about. I think it's probably more going to be this trace waters. This was done early in the semester, so it was raining a lot, and that would be my best guess. There were no visible puddles, but I do know from being in this backyard prior, when it rains really, really heavy, sometimes you step on it and it will just squish and water will come up, which could be an indication of, you know, maybe the void from the septic tank was there and they filled it and that water fills that area. The problem was I was not able to see as deep as I wanted to. So in conclusion, like I said, the desired finding of the septic tank was ruled out, but it does not mean one was not there or there still. In the future, I would like to take different survey configurations. Although I might lose the resolution, I could possibly see at a deeper depth. But more importantly, I'm very interested in maybe taking out like a GPR or just a different geophysical equipment to see if it can show me a septic tank, to see if it can show me deeper. This has to be by far my favorite of the geophysical equipment we have used, but I would be interested to take something out there and see if I can see something else. Thank you very much for listening. All of my pictures were taken by either myself or I did use from Dr. Dixit's lab in his lectures. I'm sorry I did not citation those, but I hope you learned some. Thank you very much.